Lesson 9.2 quadratic inequalities in one variable is different than 9.1 and 9.3 because now we're using the x-intercepts to split the graph. And we're looking at when the graph is less than 0, greater than 0. So there's parts of the graph that can do that. So we can have no values, we can have one value, and we can have infinite values for this solution. So example number 1, what we're going to do is we're going to sketch the quadratic part first onto our graph. So I'm going to start by putting that into my calculator, which is x squared minus 2x minus 3 for example number 1. I'm going to graph that and use the table of values to sketch the image. So what is important here is to find your x-intercepts. Okay, so what you can always do to find your x-intercepts is you can factor it. So you have to find two numbers that multiply to -3 and add up to -2. So that would be x minus 3 and x plus 1 would be less than or equal to 0. So I've just factored it, and that will tell me that my roots, which are my x-intercepts, will occur at +3 and -1 because you make each factor equal to 0 and you solve for the factor or the value of x. So what I'm going to do is once I have the graph, I'm going to sketch it using those x-intercepts. So I know one x-intercept is going to occur at 3, so you can plot that, and then -1 will have another x-intercept. I have a point at 2 and -3. So I'm just using the table of values to plot these values. I have 1 and -4. And then 0 and 3, and it's symmetrical on both sides. And I'll continue slightly up, so I'll go to -2 and 5. And on the other side, 4 and 5. So as you can see, this is a good looking parabola right here, where it's symmetrical and I can see all the main values. So the first method that we're going to use is graphing the corresponding function. And what they're doing is they're saying, when is the graph less than 0? So x squared minus 2x minus 3, when is it less than or equal to 0? This is the less than or equal to 0. Well, if you guys look, this is when the graph is less than 0. This is when the graph is greater than 0, and the 2x intercept is when it's equal to 0. So we want to describe this part of the region, this image here, including the x-intercepts, as our solution. So all we have to do is state that our graph, the orange part, is between -1 and +3. So how we would state the answer is using method 1, we're looking at the graph, and we're just saying that the part that is below the x-axis and equal to the x-axis, so x-axis and below, which is in orange, would be described by x, which is greater than and equal to -1, but less than and equal to 3. And then we would say XER, because every value in between those would be included in the answer. So this would be my solution. So it's kind of like a domain to state where your graph exists. Okay, so that's using method 1, is just by looking at the graph, we're saying when is it 0 and below, meaning when is it less than or equal to 0. So that's method 1, so it's not hard, it's just by using the graph we're looking at it. So method 2 is a method I like because it corresponds to something that you're going to learn in calculus. So what you would do is you would split your graph into the factors. So I would say that one factor was x minus 3. The other factor was x plus 1. These two will multiply to give us x squared minus 2x minus 3. And then I would split my graph into 3 regions. The regions that I'm talking about would be where x is less than -1, where x is between -1 and between +3. And we would include those equal signs in this case because of what we see right there. And where x is greater than and equal to 3. Okay, so what we're going to do is we're going to use a test point. We're going to test out a value and see what it does into our equation. And we're going to see what x squared minus 2x minus 3 would give us. So when we plug in a value that is less than or equal to -1, that could be an example of, for example, a test point that we could use for that would be like -2. A value between -1 and 3 would be 0, and a value greater than 3 could be +4. So these are test points that I'm going to plug into the x minus 3 and the x plus 1 and see what I get. For example, -2 minus 3 is equal to a negative value. So I'm just going to put the negative sign because that's all that really matters here. If I plug in 0 into x minus 3, 0 minus 3 is a negative sign as well. And if I plug in 4 into x minus 3, I get 4 minus 3, which is a positive value. So all that matters is if the answer is positive or negative. And then our next part is, let's plug it into x plus 1. -2 plus 1, we're plugging it into that and we get negative. 0 plus 1 is positive. And 4 plus 1 is a positive value. And finally, what you always do is you always multiply the signs above to get the factor of it. So we don't actually have to calculate. Do not calculate this one. The reason being is we know that x minus 3 times x plus 1 will give us x squared minus 2x minus 3. So all we have to do is take the two signs, two negatives, when you multiply them, become positive. So that's the resultant. A negative and a positive gives me a negative, and a positive gives me a positive. So the question is, where on the graph is the graph less than or equal to 0? Meaning, when is the graph negative? Well, if you look, it's going to occur in this domain right here, where x is between -1 and +3. So our result is that middle section, and we've stated the answer as in method 1 there. So I've underlined and boxed out the answer, so that's the answer that you would include for that last part as well, for method number 2. So those are just two different methods. You can choose which one you prefer, but method 2 is really helpful if you didn't have a graphing calculator, which is common in calculus. So as you go into university in calculus, you don't have a graphing calculator allowed for many of the items. So this would be a method that is very highly used because it doesn't require big calculations. Our next one, we're going to factor it first. So we're going to find two numbers that multiply to +16 and add up to -10. So that's going to be x minus 8 and x minus 2. When is it less than or equal to 0? So this is the same kind of idea. So in this one, I'm going to actually use a number line to represent my answer. So what I'll do is I'll solve for them, and I know the x-intercepts will be +8 and +2. So on a number line, I'm going to draw the value of 0. So I always like to mark off 0 where that is. And then I'm going to put two dots where the x-intercepts are. So 2 and +8. So these are going to be closed off circles. So you're going to use an open circle when you see a greater than or less than symbol, and you're going to use a bubbled in circle when you see greater than and equal to and less than and equal to. So that's why I actually colored in the circles right there, because we do want to include those x-intercepts. Now we're trying to use a test point. So I'm going to use the test point. So 0 will be my test point. And then I'm going to pick a value between 2 and 8, for example, 4 as another test point. And then I'm going to pick a value greater than 8, which could be 10 as my test point. So all I'm doing is I'm picking test points around all those x-intercepts to see which region includes my answer. So we're going to plug in 0 into the equation. So you can plug it into the original equation to see what happens. So we can go 0 squared minus 10 times 0 plus 16. Is it less than or equal to 0? So that's our question. Well, this is 0, this is 0. So is 16 less than or equal to 0? No, it's not. So that's not true. So we do not include the region that is less than 2. So that is not the answer. Our next test point is 4. So we're going to go 4 squared minus 10 times 4 plus 16. Is that less than or equal to 0? Well, 16 minus 40 plus 16. If you put that into your calculator, you'll get -8. So -8 is less than or equal to 0, so this is true. So that means this is a solution region. So what I'm going to do is kind of outline that line to show that this is where I want the answer to be. And then I'm just going to, for the sake of testing it out, I'm going to pick out 10, but I know that's not going to be the answer because it's either ever going to be the outsides when it's quadratic or the inside, but not both. So in this case, I'm going to test out 10. 10 squared minus 10 times 10 plus 16. Is it less than or equal to 0? Let's see. Well, that's going to be 100 minus 100 plus 16, so that's not true. So as you can see, we don't include that part of the solution. Therefore, our final solution will be written as that our x value, our solutions have to go from 2 to 8, which means that x is greater than or equal to 2, but less than and equal to 8, and then we would say XCR always. So that's where our possible answers could be. So any value, what you're doing is you're saying that any value between 2 and 8 that are real numbers could work and be solutions to this equation, because we're trying to find anything that would make this equation less than or equal to 0. Example number 3, I'm going to again do that sign chart. So it's kind of like, it's called a sign analysis chart, the one that I'm going to do. So first of all, we want to factor it. So I like to always factor at the negative to make it easier for myself. So that's going to be negative x squared x. And if I factor that out, it's going to change the signs to the opposite sign. So I need to find two numbers that multiply to -10 and add up to -3. So that would be x minus 5 and x plus 2. So what I like to do is then, in my chart, I like to split it as the factors. I'm going to include the negative sign with the first factor, and then my second factor will be the x plus 2. So we need to look at the different regions. Well, we know our x-intercepts are going to be 5, just from factoring it and looking at it. The x-intercepts will be +5 and -2. So I want to look at the region that is always less than the smallest value. So x is less than -2 between the two values. So between -2 and 5. So greater than -2 but less than +5. And where x is always greater than the highest x-intercept, which is 5. Next thing I do is I use test points. So I use test points to figure out what numbers I should plug into the factors to see what my final answer could be. Is it positive or negative? In this case, because we want the graph to be less than 0, we want the answers to be negative. So for example, a value of x that is less than -2 could be possibly -4. Well, we could plug that in and see what happens. Well, -4 minus 5 would be then -9 inside the brackets, but a negative times a negative becomes positive, so we have a positive sign there. So that's how we do it. We're just seeing what the sign is, not what the answer is. And then let's plug in a value between -2 and 5. Well, 0 would always work there. So if I plug in 0, it'll be -0 minus 5. And then 0 minus 5 is -5. And a negative outside the bracket will become positive. And finally, a value greater than 5 could be 6. So that could be our test value that we could be using. And so I'd put -6 minus 5, which would be a negative value because 6 minus 5 is 1, and then the negative outside the bracket makes the answer negative. And then we continue to the next row. So x plus 2, let's plug in -4 again into that one. So -4 plus 2 is a negative answer. 0 plus 2 will be a positive answer. And then 6 plus 2 will be positive. And then all you do is you always multiply the signs to get your answer. So within the region of x less than -2, a positive and a negative. So you're gonna multiply these and you're gonna get a negative sign. You're gonna multiply these and get a positive sign. You're gonna multiply these and get a negative sign. So this is where our two answers are. Those are the two solution regions that I want to include. This one and this guy right there. So how I write that is I say that I want the region where x is less than -2, comma, where x is greater than 5, and then xer, because I want to include all the values that are less than -2 and greater than 5, that are real numbers. So that's how I include or write out the answer for this. So that's my final answer for example number 3. Example number 4, I'm going to bring everything to one side, first of all, because you always have to make sure that you have a 0 on one of the sides. So I'm going to bring 12 over to become -12. And now it's going to be greater than 0. So this one cannot be nicely factored. This is where I might go to the quadratic formula, or I might graph it to find the x-intercepts. So if you use the quadratic formula or you do this in your graphing calculator, you should find that the x-intercepts are about 4.8 and -1.3. So in this one, I'm going to use the number line. So that's another method that I can do. So I can use the number line and put -1.3 with an open circle around it. The reason being is this is not equal to the x-intercepts. The sign that's greater than 0, so this sign means that don't include the x-intercepts. And then we want to plot the next value, which is 4.8. So you're always going to pick now test points between, which could be 0, greater than could be 5, and less than could be -2. So you pick values around these x-intercepts so that way you can test them out and see which region you should have the answer in. So we want to look at where the answer is positive because the equation is greater than 0. Greater than 0 means positive. So where am I going to get a positive answer? So you're going to plug in, for the test point, you're going to plug in 2 times So you're going to plug in 2 times -2 squared minus 7x minus 12. Is it greater than 0? That's what we're trying to test out. So you're going to plug in those test values into the equation. I prefer to always put in the one where it's less than or greater than 0. So -2 squared is 4. 4 times 2 is 8. Minus 7 times -2 minus 12. Is it greater than 0? So I have 8 plus 14 minus 12. So I'm putting that into my calculator. And I get that it is a positive answer. So it's greater than 10 is greater than 0. So yes, this is positive region. So this would be part of the solution region. So I'm going to put an arrow with a line because it continues forever to infinity. So I want to put an arrow on this end right here to say that it's going to be greater than less than -1.3 so far from what I found. Now let's test out 0. 2 times 0 squared minus 7 times 0 minus 12. Is it greater than 0? This is 0, this is 0. -12 is not greater than 0. This is not true. So I do not underline or use the region between negative 1.3 and 4.8. And then my last one, 5. 2 times 5 squared minus 7 times 5 minus 12, is it greater than 0? So I'll put that into my calculator as I see it. I see that 3 is greater than 0. So these two regions will be included in the solution. So I need to now outline this part with an arrow going to the right, because I want to say that the answer is greater than the x-intercept that I see. So lastly, I need to write it out and say that x, the answers for this will be x where x is less than negative 1.3, comma, where x is greater than 5, xer. Everything less than negative 1.3 will be a solution, and anything greater than 4.8 will be a solution. Or sorry, it should be 4.8. I don't know why I put 5. Okay, so you're looking at those two x-intercepts and using those to actually state your where the answer exists. Example number 5, they're giving us the equation. So this is where I'm going to actually graph it and use the graphing version for the next two. So it says if a baseball is thrown at a certain height and the height is 2 meters above the ground and the initial speed is 15 meters per second, they're giving us the inequality that we're going to use to represent this. So what I'll do is I will graph this in my calculator and find the x-intercepts. So that's what's important here, is finding those x-intercepts. So you're going to go negative 4.9x squared plus 15x plus 2. You're going to graph it. And the window that I would use will go up to 15. So I use the y max to be 15, but what I really care about is finding those x-intercepts. So my graph looks to be something like this. It's not perfect, I know. And then you're going to go second trace number 2. You're going to find the left x-intercept, which I found mine to be, the x-intercept was equal to negative 0.128 if I round to the nearest 3 decimal places. Now, in this case, we'll have to look at this later on, this answer in particular, because t, or x, in this case, represents time. So we're going to have to keep that in mind. Then let's find the second x-intercept. So number 2, second trace number 2, go to the left, or go to the right x-intercept, and then go to the left bound, right bound, and you should find that it's about 3.189. So what they're asking for is, when is this equation greater than 0? Greater than 0 is, when is it positive? So as you guys can see, this is the part of the graph that's positive because it is above the x-axis. Anything above the x-axis is greater than 0. Anything below the x-axis is less than 0. Now we are not including the x-intercepts because it doesn't have an equal sign underneath that inequality symbol. So what I want to do is say that I want the region between these two values, except that I can't include this value because time can't be negative. So I'm actually going to start from 0, which is this value right here, and say that my graph is going to go from 0 up to 3.189. So my time is going to go from 0 up to 3.189. And then t can be an element of real numbers between 0 and 3.189. And that is my solution to this question. So no negatives allowed. And example number 6 is very similar. Same idea, you would graph it. And again, the negative value can't be included. So this x-intercept, if you were to solve for it, would be about 3.56. And the other one's negative, which we don't care about. So again, we're starting from here and going up to the x-intercept. That's the second one. So again, our graph is greater than 0. So we're talking about this part of the graph that is going from time that is 0 up to 3.56, where t is an element of real numbers. And that's our solution for example number 6. So using the graph can be very helpful. You're just looking at the x-intercepts and where the graph is located, meaning above the x-axis is greater than 0, below the x-axis is where it's less than 0. So you'll notice that I did not put these lines underneath. The reason being is there's no line underneath the inequality in the question. The exit task, we're gonna move everything to one side of the equation first of all. So we're trying to find out where the graph is greater than 0. So I'm going to use those. I'm going to factor it first. So I'm going to find two numbers that multiply to -10. So that could be So it doesn't seem like there's a nice value here when you try to solve for this. So I'm going to solve this one graphically. So I'm going to find my x-intercepts graphically. So I found that one x-intercept, so it wasn't nice to factor, so I used my graphing calculator to solve the x-intercepts, one being -1.74. And negatives are allowed here because it's not a real life situation, so we don't have time. So here we can include that x being negative value. So those are my two x-intercepts. Once I find my two x-intercepts, you could do the line. So this is a number line that we're writing out, where we have -1.74 not being included, so it should be an open circle with nothing inside. So I'm going to erase that middle part. And another open circle at 5.74. Using your test values, you're going to test out 0 usually. I like that because it's an easy one to substitute. -2, which is less than -1.74, and 6, which is greater than 5.74. So we can test it out by plugging it into the second equation, because I always prefer to test it out with something that is greater than or less than 0. So I'm going to put it all in my calculator in one step. So I'm going to, in brackets, put -2 squared minus 4 times -2 minus 10, and I find that 2 is greater than 0, so my solution will be here so far. It will be where x is less than -1.74 so far. Then you're going to test out 0, so 0 squared minus 4 times 0 minus 10 gives me -10. Well, -10 is not greater than 0, so it's not going to be in this solution region. And then we're going to test out 5.74 squared minus 4 times 5, actually 6. It was 6 that I'm testing out. 6 squared minus 4 times 6 minus 10 gives me 2, which is greater than 0. So as you can see, my solution is also greater than 5.74. So x is greater than 5.74, and then we always include that xer because it does say that all the solutions after those values and before -1.74 are real numbers. So that would be my final solution for this lesson. Okay, so that is your unit. That is our second last unit. So you have 3 different methods. So you have your graphing method, where you can use your graph to figure out which part is below or above the x-axis. You can use something called sign analysis, which is very helpful for calculus, where a calculator, as when you go into university, is not allowed for something. So that's why this method is really good for not when you don't have a calculator present. And then we have our last method, which is the number line, where we plot those numbers and look around them to see where the graph is, either less than 0, greater than 0, etc. Okay. And then just keep in mind that only when we have these, the equal sign, that's when we actually include the x-intercepts. So include the x-intercepts. And when we have the less than or greater than symbol, we have an open circle, which means that we don't actually include the x-intercepts. So just to kind of